In this demo, we're going to see how we can use a Raspberry Pi as a gear defect detector using Simulink. Here's a picture of a gear defect that was detected by this demo. In terms of software, we're going to need MATLAB, Simulink, the Simulink support package for Raspberry Pi, and the Computer Vision System Toolbox. In terms of hardware, we're going to need a Raspberry Pi camera board, an Ethernet cable, and a micro USB cable. If you do not already have all of the support packages and toolboxes mentioned on the slide, you can get to them by going to Add-ons and clicking Get Add-ons. One thing to note is that in order to get the Computer Vision System Toolbox, you'll need to have access on your MATLAB license. Here is the Simulink model for our gear defect detector. It's going to take in video from the camera board and it's going to convert it into a binary image. And this is going to reduce the computation time taken by the Raspberry Pi, and it will also allow us to perform blob analysis on it later on. Once we have a binary image, we're going to perform top hat filtering, which will isolate the teeth of the gears. This filtered image will then be used to perform blob analysis on the image. Blob analysis is a technique that will allow the Raspberry Pi to distinguish the gear from the background of the image. The output of the blob analysis block will enable us to determine whether or not our gear has a defect. If the detection subsystem does not recognize at least 40 teeth, then it will assume that the object is not a gear. Additionally, it also assumes that there will only be one defect in the gear. Once the defect detection is complete, we are going to mark our image with a circle around the defect, as well as a caption which will state the number of teeth detected by the defect detection subsystem. Once the image is marked, it will be shown on the screen through the video display block. Now let's run our model on our hardware in external mode. We're going to do this by selecting external mode up at the top. And what this is going to do is Simulink is going to generate code that's going to be run on our Raspberry Pi. But at the same time, we're going to be able to monitor our system and change any parameters if we need to. Now let's run our demo by clicking the play button. And just like that, it shows how many teeth are on the gear and where the defect is. Once you know your model works in external mode, you can move on to deploy it to your actual hardware. What this does is it generates code just as it did in external mode. However, you will not need to be connected to a computer to run this demo. This is how you can use a Raspberry Pi as a gear defect detector using Simulink. Thanks for watching.